Assalamu alaikum, and I'm very happy to meet you again through this video. And in this video I would like to explain about chapter 26, which is current and resistance. I'm going to the summary part because this chapter we are going to deal only three different questions. So in this chapter, couple of topics to be concentrated. First, what is a current? The current is the ratio between the charge and time, which is I is equal to dq divided by dt, or we can write q over t. Both are correct. That's the current. The unit for current I is equal to ampere. We put the capital letter A, ampere. And the current density which is related with the current I is equal to integral of J dot dA. Here J is the current density, which is relates with the smallest area dA. And the drift speed of a charge carriers means charge carriers are here the electrons. Therefore, the drift speed is related with the current density. J is equal to NE into Vd. So, with the help of this one, we can easily calculate. We can easily find the value of Vd. Vd is called the drift speed. The drift speed is Vd, so therefore Vd is equal to J divided by N into N is the number of electrons, J is the current density, and E is the charge. And the resistance of a conductor R is equal to V divided by. This is actually everybody learned the Ohm's law. Ohm's law, V is equal to IR. From that, V is equal to IR. Therefore, R is equal to V divided by I. V is the voltage, which is measured in volt. I is the current, which is measured in ampere. The resistivity and the conductivity are explained as this. Rho means resistivity of the material and sigma means conductivity of the material. So the resistivity rho is equal to 1 divided by sigma, which is equal to E divided by J. E is the electric field and J means the current density of the material. So how can I calculate resistance? Resistance means what? How much the electrons can be stopped. The flow of electrons can be stopped. The resistance R is equal to rho multiplied by L over A. L is the length of the substance, A is the area, and rho is the resistivity. Therefore, this rho can be calculated with the help of a temperature. So if the temperature changes, the rho also gets changed. Therefore, rho minus rho 0 is equal to rho 0 alpha into T minus T0. Here rho 0 is the initial resistivity and rho is the final one, and alpha is the temperature coefficient of resistance. T and T0, everybody knows it. That's the initial temperature and the final temperature. So already we have told about the Ohm's law. The Ohm's law is nothing but V is equal to IR, and the power P is equal to I multiplied by V. This can be related with for a device which is P is equal to I square R, which is equal to V squared by R. Because what we have done here substitute the value of V. V is equal to I multiplied by R. Therefore, I square R, and then we have done the value of I value. I is equal to dq divided by dt rq over t. So when you substitute everything, you will get the power value. So these are the topics to be concentrated. Based on this idea, we'll try to solve a couple of questions. This is a revised slide. Therefore, the number of problems have reduced from 5 to 3. So only 3 questions we are going to solve. The first question is question number 9. A potential difference of 6 NV, NV means nanovolt, is set up across a 1.5 centimeter length of copper wire that has a radius 2 millimeter. How much a charge drifts through a cross section in 4.70 millisecond. So what they have asked, in this time, how much charge will be drifted? So we don't need to find the drift speed. How much charge will be drifted through the wire in this time? The wire's dimensions are given and the potential difference is given. It's so direct question, so easily you can solve it. So the formula is, we have to find the Q value. Actually, this is our formula. If you look closely, this is our formula. Q is equal to I multiplied by T, or dQ is equal to I dt. When you look at this point, we have a I constant, I value, we have a T value. But the T is given. If you read the question, T is already given at 4.70 millisecond. It is given. But how about I value? I we don't know. I have to be calculated. Then I start to recollect my mind to identify the appropriate formula to calculate the value of I. So the I can be calculated from the Ohm's law. Ohm's law is equal to Ohm's law is V is equal to IR. From there, I is equal to V divided by R. So okay, I have found another formula to calculate the value of I. So now I'm looking back by again the values. How about V and how about R? V, of course, it is given. The potential difference V is equal to 6.0 nanovolt. Then how about R value, resistance? They did not give. So resistance, we have to remember about the formula. Again, the another formula to calculate the resistance, R is equal to rho L divided by A. So rho L divided by A. Now rho means, we know that rho means the resistivity of the copper, L is the length, A is the area. So when you substitute all the values, I can easily calculate the value of R. This rho is a constant. Rho means resistivity. This is for copper, it is 1.69 into 10 power minus n ohm meter. So when you substitute the value of resistivity rho and L, length of the material, which is given again, L is equal to 1.5 centimeter, convert it, which is 1.5 into 10 power minus 2 meter, and then pi r square, because it's a cylindrical wire, the area pi r square. R is given 2 millimeter. The millimeter have to be converted to meter 10 power minus 3. So you'll get the value of R first. So using this R value and then V value, calculate the I. V is calculated from the first part and then R value. Finally, find the value of Q by substituting I and T. You will get the value in Coulomb, because the charge formula is Q is equal to IT and the unit of charge is Coulomb. So that's all about this question. When you go to the second question, question number 11, when 230 volt is applied across a wire that is 14.1 meter long and has a 0.330 millimeter radius, the magnitude of the current density is given. Find the resistivity of the wire. They given some dimensions of the wire and also how much volt is applied through it, and they ask us to, they are given the current density J, they are given the value of length and the radius R and also V. Find the resistivity rho of the wire. So how to calculate the resistivity rho? So the first, how can I relate or connect the density, current density and the rho value? So this is a formula. This is a formula which relates the current density and the rho value. Current density J is equal to V divided by L into rho. From this, rho value is equal to V over Lj. L is the length, J is the current density, and then V is also the voltage. Now I'm looking back, if I do they given the value of, do they given the value of J, do they given the value of V, do they given this value of L? Of course, they've given all the values directly, you can find it. And how do we get this value? How do we get this formula? That's a very interesting thing. So I have used two different formulas. One is current density formula. The other one is the electric field formula. The current density J is equal to E divided by rho. This is a standard formula. And then the electric field E is equal to V divided by L. So I've substituted the value of electric field value over here. That's all. So when I substitute the electric value in the current density formula, I can easily relate the current density and rho. From that, we can calculate the value of rho. Rho is equal to V divided by Lj. Now try to find, do we know all these values, or all the data are given or not? Yes. V, the voltage, yes, of course it is given, 230 volt. L, the length of the wire, is also given, and J, current density, also given. Current density, the unit of current density is J is equal to I divided by A. I is divided by A. This is the standard formula to calculate the value of current density J. Here, say here I, the unit of I is ampere, the unit of E is meter square. This is a standard formula. Then you may think about, what is this formula? This is another formula which relates a current density, electric field, and the resistivity of the material. So I use another one instead of this. Is a basic formula. Define current density means which is the ratio between the current passing through a particular area, I divided by A. And we have used another formula, and then I calculate the rho value, substitute everything. The rho unit is unit of rho. Rho means resistivity. The resistivity is ohm multiplied by meter. So this is the second question. When you go to the third one, the last question, it's very straight question. They ask us some values, all the formulas are known formulas, use the formulas, and then we'll easily calculate we could easily calculate the answer. A block in the shape of a rectangular block, solid, and has a cross-sectional area is given, and across its width, and the front to rear length is given, and the resistance of the block is given. The block's material contains this many number of electrons n is given, and the potential difference is given. All values are given. The question is, what is the current in the block? Find I. What is the current density? What is the magnitude of it, which is J? What are the drift velocity? Calculate Vd. Finally, maybe it is not properly visible, I'll read it. Find the magnitude of the electric field. That means calculate E value. That's all. How to find it? Yeah, here it is. Everything is very clear and obvious, and I'm just trying to explain the values. What is a current I in the block? So the standard formula from the Ohm's law, V is equal to I R. So from that, I is equal to V divided by R. I'm trying to find the value of V is given, R is given, substitute. That's our first answer. What is the current in the block? The second one, the current density. I have said already in the previous question, current density J is equal to I over A. I is the current, it is given. Area is also given, but excuse me, but the area is given in centimeter. So convert it, centimeter to meter, 10 power minus 2. Here it is centimeter square, therefore 10 power minus 2, the whole square is 10 power minus 4, which is the current density. The Vd, that's the drift speed of the charge carriers, J divided by Na. J is the current density, N is number of electrons, E is the charge of the electrons, which is also given. So you can easily calculate. The last one, electric field. We have already used the same formula in the previous question. E is equal to V over L. So I'll write it here. The electric field E is equal to V divided by L. So V means the voltage, L is the length of the section which is given. So when you substitute both the value, we'll get the electric field E is equal to 306 volt per meter. So these are the three simple questions. All the questions are so direct. You remember few formulas of current density, drift speed, and resistance and resistivity. You can solve all the questions. Very simple. Please work hard and read the theory part very well for these specific sections. I'll repeat it again. Current I, current density J, and drift speed Vd, and the resistance R of the material, and resistivity rho of the material. And if you read all these topics and try to solve this question, you'll find it quite easy. Thank you so much.